Another cool thing about transformations is symmetry. Even functions are symmetrical across the y-axis. So for example, if we had f of x equals x squared plus 4, if we were to graph that guy, it's a parabola, but he's moved up 4 units. But that means if we were to pick any x on the right-hand side and its opposite on the left-hand side, we will end up with the same y value. The easiest way to check if a function is even is to plug in a negative x or the opposite of x into the function, like so up here, and see if we get the original function back. So if we took our f of x and plugged in the opposite of x, then we would get the opposite of x, that quantity squared plus 4. Well, anything squared is going to be positive unless it's a complex number. So negative x squared is a positive x squared plus 4. So we did, in fact, get the original function back. Therefore, it's even. Now, an odd function is symmetrical across the origin. And you may wonder what that means. How can you be symmetrical across a point? But basically means it reflects about the x and y axes. So think about reflecting it twice. And we can also check this the same way. We can plug in the opposite of x into the function, but then instead of getting the original function back, see if we get exactly the opposite. In other words, all of the terms will have opposite signs. So if we took f of the opposite of x, we would get the opposite of x quantity cubed minus 3 times the opposite of x. So if we were to cube a negative, it gives us a negative back. So we get the opposite of x cubed plus a 3x. So we get the same thing as the original, except all the signs are changed. So it's like distributing a negative across the function. So it is definitely odd. So notice cubes are a good example of odd functions. Not all cubes, mind you. If it's shifted, left or right or up or down, it may not be symmetrical about the origin. But if you were to take that graph and reflect it about the y-axis and again about the x or vice versa, you'll get the original picture back.